Oh, this is Mr. McMurray. We're back here on lecture number 3. This one just shows a little bit, still doing our talking about the moon. This shows that as the Earth turns here, and over the period of the 29 point however many days that it takes for the moon to orbit, um, this side is facing us. It does about a quarter turn in half that time, but that means we're still facing the same side. And then here, we can't see it because it's on the other side facing Earth, is that same side because it's turning, rotating just the same amount as it's going around the Earth. But the reason that happens, we said, is because the Earth's gravitational pull keeps it lined up. All right. Okay. Anyhow, not to go on. But now let's talk about the phases of the moon. All right. If we have the sun over here on this side, as you can see, light from the sun's coming in parallel. All right. If we're on Earth here, all right, then we are on the dark side of the moon. Okay. Kind of like the dark side of Mr. McMurray's face in one of those videos where we're still experimenting with the light to get the best way here. But need to get one of those round lights. I know. Ring lights. Okay. Anyhow, but if we're sitting at this side, we can only see the shadow side, so there is no reflection on the moon, so we do not see the moon. Also, it is visible when we're at noon, which is, of course, the sun's so bright you can't see any of the objects in the sky. Anyhow, all right. Now, as it goes off to the side, kind of like as we can see on this ping pong ball, you can hold a ping pong ball. There's a mini moon and hold up the sun. As it goes off to the side, now we can see a little sliver of it that's not in the dark anymore. Okay, and as it goes around, when it's on this side, we can see a full half of the circle that's not there. Okay, that'd be like number 3 up here. Then as it comes farther, you get a little more. All right, and a little more. Once it gets, so the first one is gaining or increasing amount, so it's called the waxing crescent. Okay, and it would look something about like that because that's all we could see of it. All right, waxing because it's increasing or waxing more, getting more. All right, crescent because of the shape, kind of like a crescent roll or croissant. Okay, comes over here, we can see it's called the first quarter, which is true. We're seeing a quarter of the surface of the moon. Okay, it's half of the side facing us, which is half of the moon. So that's a quarter. Then as it begins to get where it's more than that, it starts to bulge. Gibbous is a word meaning hunchback or more than half. Okay, so it's humping back, the humpback, I guess you could say of it. It's sticking out now. Instead of flat and half right here, it's starting to bulge out. So it's called the waxing gibbous. Waxing because it's still showing more and more all the time. Now, that time it's a full moon over here. That means at night we see it. We see a full moon, and we see, just exactly that. All of them is visible. As it comes back over here, though, now the shadow starts getting in the way, and we don't see all of it again. All right. And so now we have the shadow starting on the side that before we were seeing the moon at, starts covering that up. So it's still gibbous, it's over half, or it's humped back this direction, but it is waning because now we're seeing less and less of it all the time. All right, and just move that out of the way. All right, as it comes over here, now we can see half of it. That's called the last quarter because this was the first, this is the last. Technically, it's the second quarter, you would think, but that's okay. And then waning crescent, so now we have a crescent, but it's getting less. And then, once again, when it's over here, we'd have a new moon again. All right, now, that's how the different phases work. All right, now it also affects what time of the day we see them based on its position, whether they like for example, full moon generally rises about the same time the sun sets, give or take a little bit, depending on the time of the year. Um, Waxing and waning crescents are either seen in the morning right before the sun rises or right after the sun sets. But someone says, well, but if every month the moon is between the sun and the earth once a month is between the moon and the sun, why do you not have eclipses all the time? Well, I'm glad you asked that. We're going to go into that. Okay, and here's the deal. We said the earth has its elliptical thing around the sun, but the moon, instead of going straight around the earth on that same plane, is actually tilted a little bit. So when it's in front of the sun, say over here, it may actually be above the elliptic, and so it does not actually cast a shadow on the earth. Okay, when it's on the other side, it may be below the elliptical, which means that once again, the earth is not going to cast a shadow on it. and that's kind of what they're showing down here at the bottom. So basically, their shadows miss each other. Now, keep in mind the size of these and how far apart they are too. So for the shadows to hit is not quite as easy as it sounds. The only time which they could have a excuse me, when they could have an eclipse is when they're actually lined up and they're crossing the ecliptic at the same time that there's either a full moon or a new moon. Okay, then you could have eclipses, and that's why they're relatively rare. Okay, now of the two, the more common one would be, or excuse me, uncommon one, let's do that first, would be the solar eclipse. And this is when the moon, the sun is over here, the light rays coming in, and it's putting a shadow on the earth. Okay, the dark shadow, full shadow, or totality, if we say there's total eclipse, is when the shadow is called the umbra. That's the very dark shadow. And then notice, since the moon's not very big compared to the earth, the shadow is not very big. That total shadow is a very small circle. So there's a very, now, yes, maybe a couple hundred miles wide, but it's a very small path where that goes to. And that's why you see people traveling so far distances to get there, because there's only a certain area that's going to see that totality. Now, the preumbra, okay, Preumbra. Preumbra is the partial shadow, and it is bigger. And because it's bigger, that covers a bigger area, so more people are going to see, just like we did here in Decatur and Wise County in general, and Bridgeport and so forth. We saw a partial eclipse because we were not in the totality. All right, and so there's only a small path as the shadow moves across. There's a path that's going to see the total eclipse of a solar eclipse. And so that is relatively rare and does not happen as often. Now, on the other hand, if you have a lunar eclipse, this is when the um, Earth is between the sun and the moon. The Earth casts a bigger shadow, so it covers the whole moon, and pretty much everyone on this side of the Earth is going to see it. Now, I'll be honest, I don't know that I've stayed up for lunar eclipses because of time, but if I had, they would be seen. Now, they are not usually total. They don't have, I mean, they don't completely darken it. They just get a lot darker. Okay, and so about maybe orangish red, really deep color, because there's still going to be enough sunlight that does not completely blacken it out. Okay, but there you go. Now, so that's kind of what you would see during a lunar eclipse. In a solar eclipse, you have only a very small area of totality because the moon is so small. Now, in order to have a total eclipse, though, it is kind of unique because the moon has to be the right size and the right distance away to exactly cover up the sun so that you can see the corolla and everything, the edges of the sun. And it just happens to work out that way. All right, which is really kind of cool. All right, so resuming our tour of the solar system, we've did Earth slightly and mostly about the moon, but let's move on to the next planet out, which of course is Mars, the red planet, the one that always has aliens on it and all that kind of good stuff, and the only one that we have landed on thus far. So we have had the rover that goes on Mars and check things out. We have looked at samples. We know a little bit more about it. We still haven't have a live colony there yet. And usually in the past, at least, this is the one people think of as being the most like Earth, although technically Venus is probably a little closer to that. It is on the outer fringe of that habitable zone. We said Venus is kind of on the inside, Earth is in the middle, and Mars is out here on the edge. Theoretically, it could be a place where people could survive. However, its mass is only about 1/9, so it's quite a bit smaller, relatively smaller of Earth. It has a core, a mantle, and a crust, and it has a very thin atmosphere, so not very much clouds at all or anything. So it's pretty much cloudless. It's colder because farther away, polar ice caps. It does have ice caps, but it turns out those ice caps, as far as we can tell, are made of frozen carbon dioxide, which would be dry ice, basically. So if you need to keep things cool, at least, if we're stopping there on our way to other planets or solar systems or whatever, we would at least be able to keep our food cold while we're there, assuming we have any food. Okay, that's kind of the issue there. The year is 2 times the year of the Earth. Takes twice as long for it to get around the sun. Okay. Um, the atmosphere is 95% carbon dioxide, which is kind of similar to Venus in that respect. But since you have less heat, you're not going to have much of a greenhouse effect. The temperature can range from, it does have a little bit of oxygen, for the record, 0.15%. That's about a tenth of 1%, not like we have 18 to 20% here on Earth. So it does not have much oxygen. Temperatures range from up to 30 degrees Celsius, which would be comfortable up in the 80s, mid 80s during the day, but it gets down to negative 130 degrees Celsius at night, which would be extremely uncomfortable, and we would be dead. So there are some issues there if we're able to use this as a station to go to other places. All right. It does seem to have channels that look to be carved by water. They look similar to features on Earth. So at one time there may have been liquid water, but now they're pretty much dry, windy looking areas, and there's not seemed to be any liquid water that we've found. There are methane or CH3 found in the atmosphere. We think they may be produced by volcanoes that melt underground ice to produce uh, water that leaks to the surface. Um, and there it freezes or evaporates because it's such a dry environment. The water does not stay there. But um, we think there's um, volcanoes that produce the methane, but they also may melt underwater ice to make water that leaks to the surface. But we don't think there's any appreciable water on the surface. It does have two potato-shaped asteroids, which is kind of an, excuse me, moons. And because the moons are such weird shaped, some people think that it may have been asteroids from the asteroid belt, which we'll talk about in a second, that just got captured and came and it got captured by, it got too close to Mars and got captured by its gravity, gravitational pull, and then began to orbit it instead. All right, going past Mars, then we hit the asteroid belt. The asteroid belt is not a planet, it's an area of small pieces and so forth that we think are similar to what might have formed in other places, been pulled together into a planet. But in this case, they have never, we say it's failed planet formation. In other words, these bits and stuff have never got it together and become a planet, maybe because of Jupiter has too much gravitational pull. Like we said, Mars may have had some, and it has possibly pulled some of the asteroids out to make its two moons. We're not sure, but it's we think there's approximately 150,000 asteroids in there. If you added them all together, it'd be about half the mass of the moon, so it's not a lot. Maybe that's why there just wasn't enough mass and enough gravitational pull to pull themselves together. Now, occasionally, fragments break loose from this area and from orbit, and if they do, then they can become a meteoroid. All right, and then it can start being pulled toward the sun usually. Now, if they hit the Earth's atmosphere instead of a meteoroid, we call them a meteor. So technically, a meteor is once it hits the atmosphere, and once it hits the atmosphere, friction and so forth, it will begin to melt and burn. Okay, if it has ice in it, if it's just rocky, then it's just going to get hot, overheat, begin to burn, leave a little trail. If they actually hit the surface still intact, and there are, just for the record, about 200 tons worth of meteorites, although most individual ones are fairly small. There's a bunch of them that hit the Earth, and if they're still intact when they do that, they are called a meteorite. Most of them are fairly small, although some, if you saw it shooting through the Earth's atmosphere, it looked like that, but it looked like a shooting star. And some are fairly large. I believe this was down in Arizona. They think one down in the Gulf of Mexico may have been so big that it stirred up all the dust that eventually led to the extinction of dinosaurs. It's a theory, but that's very possible. Most meteorites, the good news is, are fairly small, and the odds are on Earth that they're probably going to hit where there's no people. So occasionally you will hear about one that hits somebody's house or something, but fortunately for us, the odds are pretty low about that. All right. So after this, we're going to start with the outer planets. Okay, we've talked about the um, inner planets, and now we're ready to go to the outer planets, and then from there to the stars. Infinity and no, we won't get to go to the infinity and beyond, but you know, you can always watch Toy Story. See you in a little bit.